Okay, so this third example is that of asteroid 18172. This one does not have a common name. This is simply known as 2000 QL7. And in this example, I say it is the more difficult one. First off, because there are a lot more nights of data. So as you can see here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 different nights of data. And so that's quite a lot. And as with IVAR, it also has hundreds of images per night. This is the first night, it had 790, so you multiply that by 9 nights of data, it adds up to quite a lot of data. And so I'm not going to show all of the steps that I've done before because by now you should be familiar with them, but I will go ahead and create the data and plot it, and then we can see if we arrive at an agreeable period determination. Now, as I was processing the first photometry set, I encountered something that looks a bit interesting. This is simply a case where the asteroid passes in front of a star, and so the magnitude measurements are elevated as a result. Certainly we would want to exclude these data points from the photometry set, but if you're curious here, this is what it looks like in the image viewer. So here we have the asteroid. Again, it has passed in front of a star. And so as I zoom in here, this is the asteroid right here, and it passes in front of that star. And so that is simply what causes the elevated magnitude measurements. So it's very easy for us to go ahead and exclude those data points from the photometry set. So I can simply delete them, and now we can save the result here. So at this point, I will proceed with the other nights of images, but this is another good reason to have hundreds of data points so that in case the asteroid does have some interference, deleting those sets of data points there, percentage-wise is a very small percentage from the overall number of measurements. So that's one point in favor of having so many images here to work with. Okay, so at this point, all 9 sets of images have been processed. This took about an hour. To put that into context, Thomas, the person who provided me these images, said that it took him about a week to process all of this data. So certainly having a tool like this that can automate some of the processing really helps. And so an hour in that context is not terrible. It's actually quite good. And so the real question is whether or not we can determine an accurate rotation period of this asteroid. So again, this is the third and final example, and that means that this is the more difficult one. So I'm going to go ahead and plot all sets of data here. We're going to use light time correction and absolute magnitude, and finally we will do the period search. So I'm going to do 8,000 steps, and I'll go from 0.5 to 12, and then click Find Period. So I'll go ahead and give it a moment there. And as we can see here, it comes back with a result of 2.3745 hours, and the amplitude is 0.12. So this is certainly one of the more challenging asteroids because it has a small amplitude. So at this point, we want to know whether or not this information is valid, whether or not it is correct. So we can go ahead and compare it with other known sources of this object. Okay, so this is the Minor Planet Bulletin, volume 47, number 2, and as you can see on page 5 here, or 93 if you will, the information on the asteroid we were just looking at gives a period of 2.3767 and an amplitude of 0.14. And that compares favorably with the result we have here of 2.3745 and an amplitude of 0.12. In particular, the graph number 2 here is the one comprised of the same data that we were just working with. So if I wanted to, then I could compare these two graphs one to one. So here we have a way to do phase shift in order to get the same data points lined up. So let's go ahead and try that. And and as you can see, this is approximately the same result here. So you can kind of see this take the same shape. And if I were to adjust the graph settings here, so indeed they have a very similar result, as you can see here. And here we have amplitude 0.113, that's quite similar to the 0.12, and 4.5 versus 6.7. So indeed quite comparable, and so this is again a more challenging object just because it does have that smaller amplitude. So thank you for watching, and hopefully this inspires you to maybe create some light curves of your own. And so see you next time.